On a previous episode, I went over the history of the TRS-80 computer from Tandy Radio Shack. It turned out to be a very popular video. And in that video, I discovered that this computer right here had a number of issues. So today, I'm going to be trying to fix those issues as well as connect an expansion interface so that we can get ready to have a complete system with disk drives and tapes and printers and all sorts of things. So I'm going to be doing that along with some upgrades today, and it's coming up right now on the Retro Hack Shack. By the way, if you want to see a lot more repair videos like this one coming up, then you need to check out my second channel, Retro Hack Shack After Hours, where I do a lot of that. So check it out and please subscribe. Thank you. Well, hey everybody, my name's Aaron. Welcome back to the channel. And in a recent, very popular episode on the channel, I went over the history of the TRS-80 Model 1, and we took a look at a couple of examples I had and tested them out to see if they could work. This one was not working, and just to recap, it has a number of problems. So the first one is this connector right here between the keyboard and the motherboard. So these things often go bad. They get tough and crispy like this one is. It's really crispy. And what's happened is basically this is two pieces of plastic, one on this side, one on the underside, and there's a cable running in between here, and it delaminates. In other words, the two plastic pieces pull apart, and when they do, sometimes they pull off the metal strip that's connecting each one of these pins here. And I think that's exactly what's happened with this one. Also, it's very late and there's someone outside running their, I guess, chainsaw or something. Hang on, I'm just gonna go talk to them and see if they can knock that off.
No, Dad! I've been thinking! Good talk, Dad.
Okay, so yeah, maybe not a good idea to approach your neighbor with a chainsaw. I think on second thought, I'll just stay in here and work on this, and you'll just have to excuse the noise in the background. So the other problem with this was when I powered it on, I would get some junk on the screen and it would kind of disappear. Let's see if it's still doing that. Yeah, so there's kind of like junky characters, and then I can see maybe a ready symbol. It's there for a second and then it just goes away. So those are the two main problems. I also think I might have some problems with the horizontal sync or something because it looks like it's kind of wavy. So those are the problems that I have to fix. So this connector, I think, is the first thing I want to tackle. And because it actually is 20 pins, there should be an easy fix for this. I've seen a couple other places on the internet where people have fixed it this way. What I'm going to do is I'm going to use these angle pin headers here. So I just picked out a 40 pin angled pin header and cut it in half. So now I have two pieces, one for this side and one for this side. And what I'm going to do is I'm going to desolder and clean up these connections here. And then I'll put the pin header in, one this way, and the other one I'll put in that way. And then essentially what I'll do is I'll use a 40 pin IDE cable and I'll connect that to those pin headers, kind of like something like that. Well, this is kind of in the way, but yeah, it'll go something like this in the middle here, like that. And that should, number one, make a good connection, have a good way to pull the keyboard off. If I ever want to do some work on this or diagnosis, I can remove this instead of having this be permanently attached. I'll kind of measure that out, and then I'll cut this cable like that, and then I will crimp this other end onto this side. In fact, let's just double check and make sure that this is even an issue. I'm sure it is, but nothing there, nothing there, nothing there. Okay, there we go. Over here in the middle where there's probably not as much stress because this board is going to kind of rock back and forth like this when you take it apart. So over here in the middle, there are some that are connected, but then of course you get down here and yeah, there's nothing. So at least half of this, if not more, of this cable is not even connected at this point. So in order to make this a little bit easier to work with, I went ahead and cut the cable here so I can take these pins out a bit more easily. And I noticed that these pins are over here on the table. They're probably hard to see on camera, but you can just take my word for it that these pins just fell out when I cut this out. They weren't connected anymore at all, and they are green and corroded. So, not only did this thing just happen to delaminate, but the pins in here, the conductors, as it were, are actually really corroded. Now, I don't see any of that corrosion that has spread to either board here, so I don't think that's a problem. Okay, well, I'm just about to solder this in, and I just want to test and make sure that I can actually, there's some chips here that are going to make it difficult to get this cable in. Just want to make sure I can do it before I solder it down. Yeah, you can. You can. If you use the row that's closest to it and angle the cable down slightly to get it started, then there's enough room to push it in all the way. You just have to use that bottom row of connections. Now I'll just go ahead and do the same thing with the motherboard side of the connection. Okay, so this side of the connector was actually soldered on both sides. The other was only soldered on one. This one had solder on both sides. So what I've done is I've actually taken a knife like this, or an X-Acto knife, and I've gone through and I have cut in between each one of these pins. So now they're just down to the individual pins. And then what I can do is I can grab on to the pin with my needle nose pliers, and then I can heat up each joint or each area individually, each pin individually, and each pad. That's what I was trying to think of. Each pad and each pin individually. And I just heat it up and come on. There we go. They come out one at a time. A little bit more time consuming, but it's not very difficult. So this will get done in just a minute. Okay, so I've been playing around with this a little bit. I've got all this cleaned up here on the motherboard side as well. And I'm about to put in this right angle header, but I wanted to make sure I had enough room to connect the 40-pin IDE header, since it is a double width header. It's 2 rows of 20. I wanted to make sure I had enough room to actually fit this on. So what I've done is I've taken one of the spare headers I have here, and I've just kind of wedged it in a little bit, kind of propped it up on this chip here so that it's at a little bit of an angle, and that should help me actually be able to have enough room to plug this in once it's all said and done. But now I'm going to turn this over and solder in the other header on the main board. Now, I should mention as I'm doing this that you only want to apply as much heat to these pads as is necessary, because they are old and they can become delaminated from the board. They're held on there with, I'm not sure exactly what, some sort of epoxy or glue, the actual metal pads here. And you heat them up too much, especially when there's corrosion on there and stuff. You heat them up and they can come off. In fact, one of the pads, pad number 20 on this, did come off, and that's mainly because it wasn't connected to anything. So it's lucky for me that it wasn't. But at the same time, heat is kind of the enemy of these old pads. Okay, now I've cut one of these cables off to the distance that I think it's going to be. I went ahead and kind of dry fitted this to measure, and it looks like it's going to be right, but I don't know what that is. 2.5 inches, it's about 3. If I was going to make this from scratch, I would make the cable 3 inches long. So now what I've done is I've slid the cable into the fitting here, into the socket, and then I like to press down a little bit just to make sure that it doesn't move around too much before I crimp it. And luckily, I am fortunate enough to have one of these IDC crimpers that I use when I make all my cables for the RGB to HDMI product I sell on my website. But you can just fit this in here, and then it's got a little notch right here. And the IDC cable, you'll know when it's in the right spot because the IDC cable kind of goes into that notch. There we go. It's in there now. And now all I have to do is press down tightly, firmly, whatever. There we go. A little bump there. And got a nice brand new 3-inch IDC, 40-pin IDC cable. Okay, so it's time to give this a try. Remember, when you're fitting this on here, because of the orientation, if you use the upper row of pins here, or in this case, I'm going to use the lower row of pins on this side, then you need to make sure that the mating pins are the upper ones on this side. I hope that works. So it's outside to, is that right? No, sorry. So it's going to be the outside of this one, I guess, to the inside of this one is the way that it's going to work when you put this together. If you have any doubt, just plug in a couple of pin headers and test it with your multimeter so that you make sure that you get pin 1 on this side matching pin 1 on this side. There we go. That angle does help it to get in there, but it should be connected now. And it's about an inch apart when it's spread out like this. And when I fold it over, there should be just enough room for that to go in just as it would have with that other cable. So very nice. I'm just going to go ahead and tone out all of these to make sure that everything is connected. Should be good to go. Much nicer solution that's easily taken apart when you need to work on the system. Okay, so I should mention that you don't need the keyboard connected to have the computer function at least a little bit so that you can see if anything's coming up on the screen. So you're not just going to get a black screen if the only problem is a disconnected keyboard. Okay. Well, actually, we're seeing something a little bit better. So I think we were getting what we were seeing before was some random keyboard presses or like floating keyboard signals that were causing random characters on the screen. I know it's hard to see like this, but at least now I'm getting just one line of text and it disappears too quickly to see it, but just one line of text there, and that one line of text may very well say memory size. So now let's see if I can figure out if there's a vertical or a horizontal hold problem here or what's going on. So the horizontal hold is one of these two pots here on the edge. Nothing yet. Oh. Look at that. Did you see that? Because it says memory size. So clearly there's a problem with the horizontal hold on this particular board. And the horizontal potentiometer over here doesn't seem to have any impact on the horizontal setting. It seems to be almost floating or fluctuating. So I think the first thing to do is to measure this pot and make sure it's still working. And to do this, you measure the center leg of the potentiometer, the one that's at a odd angle from the other ones. Usually it's offset a bit. And you measure the one of the legs, either one of the other legs. And right now I'm reading 100K, almost 100K, 99K. And if I just move this with my hand, let's see, that's a little over 100. Yeah, now it's going down, 73, 72, 43, 7. Yeah. So as I go through the range on the potentiometer, it is actually working just fine. So the potentiometer is not a problem. Now I looked at the schematic for the Model 1 here, and this particular potentiometer, it's R20, sits right smack dab in between a couple of lines on the Z6 chip. And in doing some other research, I found that this chip and a few of the other ones, Z6, I believe it's Z5 and Z57, all have sit in the path of either the horizontal drive or the vertical, and have to do with combining the sync into a combined sync pulse that goes to the monitor. So these chips do go bad, and I think it also might have to do with the fact that, as I mentioned on the previous video, all of these DIN connectors here are the exact same 5-pin DIN, and it's very easy to put the power where the video should go if you're not paying attention. So perhaps that happened on this particular board, and it either fried one of these chips, maybe one of the connections or internal workings of one of these chips, or just made it unstable. Because right now, when I turn this on, like I get nothing immediately, where I used to get a little bit. Now I'm just getting a little bit of garbage on the screen, or maybe something like a little bloop on the screen. And now I'm actually getting nothing, not even for the short amount of time that I was getting it before. That kind of leads me to believe that there is definitely a problem internal to one of those chips, because what can happen is, perhaps as that chip heats up, for example, and things expand, maybe you would get a connection for a short period of time, or something would work for just a tiny bit of time as that connection expands, and then maybe, doesn't make a good connection. You could also play around with applying some heat or some cold to these chips to see if you could identify one or the other that's not working. And of course, you could probe around with your oscilloscope to find that as well. But since this is a very common known fault, I'm going to go ahead and replace these chips. One more thing, all three of these chips are CMOS logic chips. That is important because the specific timing that this system is built for requires those higher speed CMOS chips. What you wouldn't want to do is put a 74LS04 in there because it would probably give you some bad results. So I went down and found some 74HC04s. So those are the high-speed CMOS chips, and that should be a good replacement, of course, assuming in all of this that that is the problem. So I'm going to go ahead and grab my desoldering iron and take out this chip to start with, which is right in the middle of the path of the potentiometer, as I said, and that is Z6. So we'll take that out, put it in a socket, put in one of these newer chips, and see what we get. Okay, and through the magic of video editing, voila! That socket is now in place. There we go. Okay, the new chip is in. It's in the right orientation. Let's turn it on and see if our horizontal comes back. No. No, it does not. All right, so the next thing that could be in the way of the signal, causing, like if there was a bad pin or something, is this Z5 chip. This is what combines the horizontal and vertical into the sync signal that gets sent to the monitor. And if the input side of this was bad, receiving that, then that could also cause the changes in the potentiometer not to register anything on the screen. So I went ahead and socketed that chip. Now there's one more after this that I may have to do if this doesn't fix it. There's also a couple of transistors and capacitors in here that could cause problems, but for now, I've changed out that chip. Let's just go ahead and see if we get any different results. Oh, look at that. That was it. It was the Z5 chip. It was the chip that combines the signals to go out to the composite sync. And there it is. I mean, right away, boom, fixed completely. I haven't even tuned the horizontal position yet. So yeah, now we're moving. Still a little jerky as I push on this pot. So, you know, that pot isn't great, but now that's exactly what I would expect. I would expect it to move left and right, and that is what it's doing. But the verticals were moving as expected, horizontals moving as expected, and we have finally something we can see on the screen. Yay! And also can see if the keyboard is working after my keyboard mod finally. All the keys are absolutely working. Now, there was some, for example, in this K here, there was some bouncing going on, some double characters. And what I did was I just, exercised the heck out of that key because it hasn't been used in probably forever. And now single presses almost every time. I just got one bounce there. Let's see. It looks like J was doing that as well. Yeah, J's doing 2 J's. And now you can see what I'm doing here. I'm just exercising the J key. So I'm just going to press that, and I'm going to do the old thing with the arcade. Like you got to pretend that you're playing 88 games in the arcade where and you're really trying to work up that score and go fast in the sprints. You kind of like freeze up your hand and go crazy. And look, now a few bounces, but it's a lot better. So all of that to say that I think that the double letters and things that I'm seeing are due to dirty, crusty keyboard and not due to something in the circuit not doing the debounce correctly. There was a debounce fix, I know, between the very first version, I think, and subsequent versions, because there was something in the circuitry that was causing that to happen with the key presses. But I think that they fixed that by the time this 1978 version came out. I could be wrong. Let me know in the comments what you think. But definitely just exercising that. I was getting double keys every time. Now I'm getting them once every 3 or 4 times. However, I do want to see how much memory it thinks it has. And I think I can do print mem or question mark space. I'm typing upside down on the keyboard. MEM, enter. And there we go. Yeah. So 4K, I'm sure some of that is taken up by BASIC, so it comes back with 3284. I think that's normal. I'll have to look it up. But yeah, this looks like it's completely working. Let's talk for a minute about the way that Tandy Radio Shack decided to attach peripherals to the TRS-80 Model 1, and that was through another box called the Expansion Interface. Unlike other systems at the time, like the Apple II, the TRS-80 Model 1 didn't have card slots internally where you could connect cards to connect to peripherals outside the unit. Instead, Tandy Radio Shack decided to have an all-in-one box that could connect to disk drives, printers, modems, and all sorts of other things. In fact, there was even a voice synthesizer, something very popular at the time, and a voice recognition box called the Vox box that you could attach to the expansion interface and speak to your computer, and it could speak back to you. One of the main reasons to use the expansion interface was to expand the memory, because the memory in the Model 1 could only be expanded to 16K, but with the expansion interface, you could add up to 32K additional memory, and this would greatly increase your memory footprint. The expansion interface had discrete ports for things like floppy disk drives and line printers, and it had multiple cassette ports, so you could actually copy your tapes right from the computer from one cassette deck to another one. As we'll see in a minute, the expansion interface also had a compartment where you could put not only the power supply brick for the expansion unit itself, but also the one that went to the Model 1. You can imagine that this would clean up your desk quite a bit. There was another compartment in the expansion interface where you could put other cards that could be developed for the expansion interface in the future, similar to the RS-232C card that would be used for communications and modem use. With all of these discrete connections that it had, as well as the expandability, it is a very unique way to connect peripherals, but you got to remember this was early days, and things like the IBM PC hadn't even been released yet, so there was no commonly agreed on ways to connect peripherals, and for its time, I've got to say, the expansion interface, as odd as it seems today, really did get the job done.
All right, well, here's the first expansion interface, and just like the other one, the first thing I want to do in all my testing with these types of things is to test the power supply. On the expansion interface, there's a compartment here where I believe you could put both power supplies to hook up to the TRS-80 Model 1, one for the expansion interface and the other one for the TRS-80. Let's just take a look in here and see what we've got. There we go. Okay, yeah. So this just has a single TRS-80 power supply, and boy, it's like, because it's been in this case, it is like brand spanking new. There's this, I mean, it is like the day that it came out of the store. It's one of those pull type, yeah, here we go. So it's one of these pull to release 5-pin DINs, but it's just the same power supply as the one that would power up the TRS-80 Model 1. And it just plugs into a little port there on the side of the motherboard. So I do want to test this. Do I have my test harness is the question. And yes, I do. Here it is right here. Oh, 2 volts. That's not good. Maybe this is a bad power supply. And look at that, we're in luck. There are screws under the feet of this power supply. So let me get the expansion interface out of here. We can see if we can fix this one. All right, well, I got this thing opened up. By the way, I did confirm that the AC voltage was not working at all either. So I got this thing opened up, and I was going to check, because I'm pretty sure this is the fuse here, right? That is going to be on the AC side to make sure nothing's wrong. And when I went to pull this out, look what I got. There's a resistor in there. But if this is the fuse here, then this is probably why this isn't working. By the way, this is unplugged. Here's the plug right here. But yeah, not sure exactly what happened, but definitely not going to work like that. And also, this is super janky, not even soldered on. Look at that. This isn't even soldered. So someone just like wrapped this on there and threw this in. Maybe it broke at some point and somebody tried to fix it previously. Yeah, let's see what the other side looks like. Oh, okay. So there's the actual, what would have been the other part of the fuse, and this would have been in there like that. So yeah, that's not going to work. So let's hook up a new fuse and see what happens.
So just like with my other video I did on the second channel about fixing up that other power supply, I'm going to be using one of these little teeny tiny 2 amp fuses. And we'll put this in the case and it should be good to go. If we ever need to fix it, just open it up and switch it out. Somebody on the second channel recommended the self-healing fuses as well. I just don't have any of those. It's not a bad option. I think they're a bit more expensive, but yeah, that would probably be another choice as well. In case you're wondering, here's what that underside of the transformer looks like. And it looks like they just have 2 diodes right here. It's going to be kind of hard to see on film, I think, but because they're underneath this cellophane. But on these 2 leads right here, there's 2 diodes. So it looks like this is set up to be like half rectified or something like that, which is why the DC voltage is 17 volts instead of 12 volts. It would be higher with that half rectification, but it looks like that's what that's set up for. I did test the other 2 leads, which are the 19 volt, where the 19 volts AC is coming from. I tested those and those are reading good. So no shorts there. The transformer seems to be working as they almost always are. And I also tested on diode mode these 2 leads here, and the diodes test good. So with that janky fuse now fixed, we can test this out, see if we're getting the right voltages. Okay, I know this looks janky, by the way. Do not work with live mains voltages, especially if you don't know what you're doing. So this is live right now. If I was to grab this with my hand, I would get a nice 120 volt shock, which I do not want to do. Also, I've spaced out these little connection leads. I hooked up some yellow ones to test AC. I've got other wires spread out. I know it probably doesn't look like it on camera, but I am trying to be somewhat safe. All right, so let's go ahead and plug this in and see if we get any readings. I'm going to go ahead and turn on my multimeter to AC mode. I know you can't see it over here, so you'll just have to take my word for it, but here we go. All right, plugged in, and I'm getting 20 volts AC now. Yes, 20 volts AC on the AC line. Let me unplug this, and I'll test the DC line. We should be getting something close to 17 volts DC there. Okay, I found a way to work the meter into this tight shot here. So I'm hooked up to DC voltage. One last check just to make sure that the ends of those wires are sufficiently separated. Nothing near the AC. So let's see what we get on the DC voltage. And we're getting 19.39. So everything is just a little bit high here. Maybe those diodes are a little bit worn out. I don't think so, though. I think this was probably always high. So yeah, this looks like a good power supply. So instead of throwing it out, we fixed it and we're ready to go to test the expansion unit. Now, fuses like that don't normally blow themselves. Usually something has to happen. It could be because of an inrush of power, I guess, from a lightning strike or something. But maybe there's something wrong with the expansion unit itself that was trying to draw too much power. Maybe there was a short or something. So I think I was just going to test this out, go for broke, see if it works. But I think because I found that bad power supply with the bad fuse, I think I better check this out. And that's not the only reason either. There's a screw right here. Most of them look clean, but this one right here is a little rusty, crusty, corroded. There's a little closer look there. You can see how rusty that one is compared to the others that look pretty good. So, and that would be about where the power supply would have plugged in. So maybe somebody spilled something on this at one point and maybe that did it. I don't know. On the other side of this unit, these are also a little crusty, not as bad, but these 2 right here, you can see have some corrosion on it. So yeah, I think it's best just to open this up, make sure there's no shorts or any obvious things going on inside. All right, well, I've got this off. We'll go over it in a minute, but there's something. I've got all the screws out, but I can't quite get this off. It's like it wants to come out. Okay, let's see what's in this. Oh, there's something in there. I knew that they had this little expansion hatch here, but I don't think I've ever seen anything in there. Is this like a modem card maybe or something? I don't know. But this is why the board's not coming out. It's because it's got this, whatever, some sort of expansion. I'm seeing this Aztec module. Anyway, I'm going to have to get this thing out. I just want to do a thorough inspection of that expansion motherboard. Yeah, let's see if this will come out now. Yep, it did. Oh, That's not a great way to do it. It's a press fit to this board here. And yeah, those contacts, I don't know if you'll be able to catch this on video, but they are definitely corroded. So not a great way, I would say, to connect an expansion unit. I'd rather much have a plug-in force fit kind of connection, but oh well, that's what it is anyway. So this is out of here. We can take a look at the other board. Come on. There we go. All right, well, before I hook this back up to the main computer, the TRS-80 Model 1, I want to test this expansion interface out just for power to make sure everything power-wise is working and there's no problems. I have it turned off right now, and there should be 5 volts, 12 volts, and negative 5 volts on this board. So let's see if we can find them. I took a look at the schematics, so I have some ideas of where they should be at on this board. A couple of regulators here, one's for 5 volts and one's for 12 volts, vice versa. And then negative 5 volts will be derived probably off the main transformer or off of one of these units here. So let's go ahead and turn it on and just make sure the smoke test is good. Remember, the fuse was blown in that power supply, so you know there could be something here. Even though I've tested for shorts, you never know. So let's see what happens. I didn't hear anything pop. It should be ground here on this cap, and then these regulators. If I test this one, hey, there's our 5 volts, a little high, 5.2. Might have to dial that down just a bit, and then this one up here, I'm assuming is 12 volts. Yep, 12.15. So that is good enough for government purposes, as my father would say. Oh, and I should probably find the negative 5 too, just in case, just for thoroughness. And I know that I think C1 through C8 up here, there should be a negative 5. Yep, there it is, negative 5.2, just the flip side of the 5 volt rail. So yeah, we're all good in terms of voltages on this board. Okay, the other thing I want to do too, before I put this back in the case, is just clean up these pads, which are notorious for corroding or getting dirty. I mean, they're not gold plated, they're just tin, I guess. So I'm going to take an eraser and just go over all of these pads with an eraser and try to clean them up. And also, I'll finish that up by putting a little deoxit on each of these, all of these edge connector pins here, because I want to make sure those are good. They are recessed into the case, and you know, if they're not clean now, then I guess I might be able to take a cotton swab and some alcohol and clean them off, but it's going to be much easier to do at this stage with everything taken apart. Okay, so I noticed when I turned this back over and was putting the screws on that I was missing 2 of the feet. I've got 2 on this side and I've got none on this side. So I do have an assortment of feet that will match. Yeah, that's the exact same height, but you know, these are different. These are not going to match. And so I'll just have to put these on temporarily with some Scotch double stick tape. I'll put these on and then, yeah, we'll see how they work for now. They'll do the job for the moment. Now, one of the nice things they did with the expansion, because, you know, if you had all this stuff stacked up separately, it would kind of take up a lot of space. And the monitor always sat kind of low behind the TRS-80 Model 1 anyway. So with the expansion interface, what they did was they put it so that the TV could sit into these little indents here and sit on top of the expansion interface. So hopefully, if we've got this right, let's see. Yeah, there we go. Perfect. So the original TRS-80 and expansion interface, not only did they have dirt and corrosion that could happen on the edge connectors here, but they also had problems with the cables, and they actually had to come up with a new solution, which was this expansion buffered expansion interface cable. It was not buffered originally. But to remedy some of the problems, they came up with this expansion interface, and it's got some buffering here built into this little black box. So I'm just going to go ahead, because these connections are always so unreliable, I'm just going to go ahead and put some deoxit on both sides of this before I connect it up, just to hedge my bets here that this is going to work. So boy, that doesn't look very good, but it should work. And because I don't have a disk drive plugged in, I think I need to hold down break when I turn this on. Let's see what happens. Yep, there we go. Memory size. Otherwise, it would have tried to boot up the disk drive, and since it's not attached, it just would have sat there. The computer would have sat there and really done nothing, which could be a trick. If you plugged everything up, including the expansion interface, and turned it on and didn't see anything, you might think it's not working, but when really it's because with the expansion interface, it's trying to automatically boot from the floppy drive, which is unconnected. And so you get a, system that's seemingly non-responsive, even though it's trying to do something. Anyway, let's see if the expansion interface is at least somewhat working. And the way that I'm going to do that is I'm going to ask how much memory. I'll just hit enter, Radio Shack level 2 basic. And now I'm going to type in print mem and we'll see what it comes back with. Remember, the original system is 4K or something a little less than 4K, and we should have an additional 32K. So something in a range of, 35 to 3600 bytes of memory. So let's go ahead, kilobytes of memory. So let's just go ahead and do print, whoops, a little bounce there. Mem. Another bounce. Mem. Okay, here we go. Nope. Nope. Not working. Expansion, it either doesn't see the expansion interface or something, because it's still only giving us that same amount of memory. Okay, so I'm trying to eliminate whether the problem is the expansion interface or the TRS-80 Model 1 or something to do with the cable. Now, this is the second Model 1 that I showed in my history video. There was 2 Model 1s. This one worked fine out of the box, so to speak. No problems. And it has 16K of RAM. So the differences are newer model, 16K of RAM. And when I got it, it had this straight through expansion interface cable plugged in with it. So it hadn't been disconnected. So I'm pretty sure this is the correct cable to use with this more modern Model 1. So all that being said, I just wanted to see if the expansion interface would work with this unit that I think is using the right cable, because there are those different cables that you need. So let's go ahead and turn this on. Hold down the brake key and hit the power button. All right, we get the mem size here. So I'll just hit enter. Now, interestingly enough, when I hit enter on this, it took a little bit to come back with the Radio Shack Level 2 Basic. And it's also a different version of Level 2 Basic. I can tell because it says mem size. I think the other one says memory size. And this one says R/S Level 2 Basic instead of Radio Shack Level 2 Basic. So there are definitely some differences going on here. But let's go ahead and do the question mark for print mem and see what comes up. Oh, okay, here we go. So 48338. So this is seeing the full 48K of memory that it should see, 32 in the expansion interface. And in this case, this one has 16K internal for a total of 48K. So, okay, there's something either with the Model 1 that I was using before, which is up here on top of the monitor now, or with the expansion cable. So at least that lets me know that this expansion interface is actually working so far. I mean, there could still be problems with the floppy disk controller or other logic chips and things like that. But at least so far, that shows that the problem most likely is not the memory in the expansion interface, and can move on to troubleshooting a little bit more pointedly with this original Model 1 that I have up here. So the biggest difference between, well, not the biggest difference, but one of the differences between this older system and the newer system, as I may have mentioned, is the amount of RAM that is installed. This one we confirmed has 4K. The problem with that is, in order to use the expansion interface, you need to first have 16K configured in the Model 1. And I think that's why this is not working. It took me a little bit to actually figure that out, but I did some digging, and this is an example of RTFM, I guess. If you go to the original user manual for the expansion interface, it says in there, slightly ambiguously, I would say, that you need to first upgrade your original system to 16K and then you can expand the memory further with the expansion interface up to 32 additional K. And I think the idea was you would buy the expansion interface. In fact, I'm pretty sure they sold it without any memory. At least one option was to buy the expansion interface without any memory at all. And then users would upgrade their Model 1. And then when they filled that up, they could add more and they could add more. So you could add 16K at a time to the expansion interface. And finally, you would get up to 48K. So with that in mind, I figure a simple test of this theory here is to go ahead and install additional memory in the Model 1, bring it up to 16K, and then see if it picks up the rest in the expansion unit. So if I replace the existing memory in the system with these 4116 memory chips that I happen to have here in my spare stash, then we should be able to test that theory out. And for those of you playing along at home, which are curious, these are Motorola 6604 chips that were produced in 1978. So we'll take these out and swap the other ones in. There we go. Chips are in, but we can't turn the system on just yet. It's not quite that easy. Just like the IBM PC, the original 5150 that IBM released, and several of the subsequent models, 5160, I think even the 5170, they had settings on the motherboard to tell the system how much memory was installed. In this case, there are two shunts. Instead of dip switches, they have shunts. And when you bought your memory upgrade, it would have come with some new shunts to put in here to match the type of board you had and how much memory you were installing. So you would have got your memory chips and you would have got the shunts, and you would have had to make sure that you put those in the right place. In this case, I don't have the right shunts to go along with it. And there are different versions for different boards. So definitely something to keep in mind. But what I do have is I have some dip switches, which will be easier. If I get something wrong, I can actually just go in and fix whatever I did. So I'm going to replace the shunts with dip switches, and then I'll be able to make modifications more easily. Hopefully I get it right the first time, but if I don't, this will allow me to come back and change it without having to create some sort of special, solder blobs or use wires to fix the shunt connections that are not in the right place for 16K on this particular revision of the motherboard. And it looks like my board is revision G. There was an A, I think there was a D, and this one is revision G. So for those playing along at home, here are the dip switch configurations for the Model 1, depending on what version motherboard and what amount of memory you have. And I found this in a book, and I'll put a picture of it here in the video, and it's called the Custom TRS-80, and it is chock full of explanations about how things work, troubleshooting tips, and tons of mods that you can do, including there's one to take the 4K of memory that you had left over, and instead of throwing it out, you could actually build a mod board that let you use that 4K of memory. Just all kinds of really cool things, but really glad that I found it after I started having this trouble where I couldn't see all the memory, because it's answered most, if not all, of my questions that I had about, things like how to do this memory upgrade and things like that. So really good resource. Highly recommend it. And it's amazing all the knowledge that people put into those books back in the day. What a great resource to have now for us that are into vintage and retro computing. If you have a favorite resource, not just for the TRS-80, but for any computer, like the, what's the Macintosh cookbook or Bible or something? I know I've got that one as well for Macintoshes, for example. If you have any resources like that, that are your go-to guide for doing this sorts of troubleshooting or understanding how systems work, put a link to them in the comments below. I would really appreciate, seeing what the community likes and as their resources for doing this type of troubleshooting and learning about these old systems. Okay, so with the memory installed, we can power this up. I'm just going to power up the base unit first and make sure that I can see all 16K here on the actual Model 1 first. So here we go. And we're getting junk on the screen. So maybe one of those memory chips is not working. All right, well, I've been doing some testing, and I think I figured out the problem, and that was with some bad assumptions. You know what happens when you assume, right? So when I was looking at these dip switches, I noticed that there was a 1 up here. Now these dip switches may have been custom made for some application or whatever, but I noticed there was a 1 up there. And to me, 1 means on, which means connected. And so, for example, I believe if I've got the shunt configuration correctly, this particular shunt would have been the one that's up here. It's called Z3, chip Z3. Oh, you can't see that. It's right here, Z3. Would have had all of these on. And so I put them in this position. But things weren't working. I tested all the memory. Things looked okay. So I pulled this out and did a quick test. And it turns out that the on position for these dip switches is the other way. It is down. So now this is on and these are all off. So yeah, to me, that's unintuitive. Let me know in the comments below. Should I have known better? Is 1 always towards the number? I don't know. There's usually a marking on the side that says, a little arrow that says on or off, but this doesn't have that. So anyway, good to check even the most basic things like this. I'm going to switch all of these the opposite way that they are and on the other one that's in there, and we'll see if we get a better result. Okay, I've reversed all of my dip switch settings. Let's turn it on and see what we get. Hey, no keyboard, so that is actually normal, but we're getting memory size. So let me add the keyboard and we'll see what kind of memory we're getting. Memory size, baby, memory size. Hit the old enter key and let's do a question mark. Gotta debounce these keys. MEM. There we go. 16K of memory. Now, let's hook up the expansion interface and see if we can see the rest of the memory in the expansion interface. Oh, I forgot I have to hold down the break key. There we go, memory size and enter. It takes a little bit like the other system did after I hit enter, so I think this is a good sign. Question mark, MEM. Yes! Okay, that was it. 48K of memory. Yes. It's the simple things in life. But yeah, so the problem is if you're restoring a system like this and you come across a 4K machine, you are not going to be able to use the expansion interface until you upgrade that 4K machine to 16K, and then you'll be able to see all the memory. All of this to finally get to the point where I can say that the expansion memory or the expansion interface is at least running. Whether it's completely 100% working, we'll have to find out when we take a look at the disk drives. Go away, fly. Well, finally, I have the main system working, the expansion unit working, tested, working, everything's working great, but we need to be able to play some software to finish this thing up until next time when I talk about preparing the drives and getting software loaded and really checking out some of the amazing software, hopefully, if I get the drives working, for the Tandy Radio Shack TRS-80 Model 1. So anyway, I thought, what better way to showcase and celebrate getting this thing working than by actually playing the pack-in game, as it were, as you might call it in the UK, right? The game that came with the system. There were many of these over time. I believe for me anyway, Atari was Combat. Sega Genesis was Sonic the Hedgehog. The NES, the Nintendo Entertainment System, would have probably been Super Mario Brothers, I think, when I got mine. It's hard to remember at this point. But anyway, this computer came with one of those included games as well, or actually two of them. And when I picked this up, included was the original cassette that came with this, because this would have been the easiest way to load programs without the expense of purchasing an expensive floppy drive. So this came with two games on this cassette, Blackjack on one side, and on the other side, backgammon. So you could load these, so you had something to do besides just typing in programs. You could actually load these off your cassette player into the computer, hopefully, as we'll find out probably, and do something with your computer right away. That was a lot of fun. So I went ahead and grabbed a Panasonic cassette recorder, and this is the same one that I used with the Apple I, so I know it works with older systems that don't perhaps have an advanced cassette or data recognition system built in. So let's just go ahead and pop in Blackjack here and see if it works. Now on the TRS-80, the way that you loaded programs from cassette, and by the way, they carried this over in BASIC to the TRS-80 color computer. It was the same command, and that is cload. And I still have some bounce here that I'm going to have to fix. Add that to the list. Type in the cload command, hit enter, hit play on the tape, and we should see, in a minute, we should see a star over here in the corner, I believe. Okay, no star. What the heck's going on? I mean, I can't guarantee that the program's going to load, but I at least should see the star once it recognizes the data is streaming here. Oh, duh. Yeah, it always helps to plug in whatever you're trying to interface with the computer. In this case, the cassette cord, the original cassette cord that goes out to the speaker output, the microphone input, and if you have one, an auxiliary jack to control the cassette starting and stopping automatically, which is really cool. Anyway, this was not plugged in. So let's plug this in and see if we get a different result. Okay, and I've set the volume on this to be similar to the way I had it on, oh, there we go. There we go. The star is blinking. There's a solid star, and then there's another one that's blinking, I assume, as it's taking in bits of data. I'm not sure exactly what the blinking rate represents in this case exactly, but it definitely gives you an indication that it's loading data. And what was I saying? Oh yeah, I was about to say I've got the volume set the same way it was for the Apple One. So it's like, for me, this is on like 70% volume, whatever that equates to. So let's see if this actually works. Oh, there it goes. I have to stop the tape manually because I don't have an auxiliary port on this particular cassette recorder. It says it's ready. I believe this is a BASIC program, so we should be able to list it. There we go. There's the program. And hopefully we're not missing any lines because, yeah, you know, if the tape signal isn't strong enough, or it can't read it, or maybe it's warped, you can't decipher, you know, basically what interprets the ones and zeros in this case going into the system, you could be missing lines or stuff could be screwed up. But this all looks at first glance like it perhaps is there. So let's go ahead and run it. Okay, so far so good. One or two players. One or two decks. One. Ooh, what's that smell? No. I think I just lost a chip. Ah! Oh my word. These old systems are very touchy. Ooh, yeah, I bet it's this one right here too. Because that one's super hot. And the chip next to it's pretty hot. So one of these two chips, I think, fried. Now it might not be a memory chip, but this chip is hot. I mean, this has been powered off for 30 seconds, 60 seconds. This chip is definitely hot. Okay, I'm just going to turn this on and then verify that chip is the one, or whether it's just, you know, if it's really hot or just sort of hot or what. So I don't even have this plugged into the monitor. I'm just going to turn it on and feel these memory chips and see if this one at the end is really hot. Yeah. Ouch. Ooh, yeah. That's hot. Woohoo. Now that chip, yeah, I bet I don't know what I would bet. A lot of money that chip is dead. So need a replacement. Ow. Good thing I got my tetanus shot. Yanked that chip out of there. It left imprints in my poor hand. I'm bleeding. What happened, by the way, is I was yanking that chip out with my fingers because of the dioxide I put in there. It was pretty easy just to pull out. And I pulled out kind of hard, and when I did, it kind of twisted, and then the pins went into my end of my finger. New chippy is in there. Let's hook up the video. Just do a quick test, and then we'll skip back to playing that Blackjack game. All this for a Blackjack game. Let's see. Oop, that was on. Okay, let's see if this works now. No, we're still getting garbage. Well, they're not getting hot, but... Ooh, that one is. That one is. I got another bad one. Two of them went, apparently. I wonder what happened here. I wonder if there was some sort of a short that took out... Yeah, that one right there took out 2 of these chips. Well, I'm out of chips. I'm going to have to go look and see if I can find another 4116. All right, well, I'm out of 4116, so I'll have to order some more. I just pilfered one from the working system, so at least I know that this chip is working. Okay, I think this is on. Let's see if we're back in business. Yes, we are. It's just doing that because the keyboard isn't connected. Okay, back at it. All right, here we go again. We got the stars are aligned up there in the corner. Let's see if we can give this one more go before I lose any of those other memory chips. There we go. It's done. Let's run it. All right, we're back where we started. Let's see if it'll go. 1 player, 1 deck, 1 name. Now I'm noticing the screen is flickering a little bit. It says it's shuffling. Screen is flickering a little bit. I must have bumped that pot with the horizontal positioning pot when I put it back in. Okay, place my bet. Let's place 500. Diamond. So let's see, I think this is me. So I've got a 10 of diamond and a 6 of diamond. He's got an ace. Oh, come on. I'm going to lose this hand. I'm just going to say I don't need insurance. Blackjack, lose. Yep, I knew that was coming. Now what? Place bet. Okay, so I'm at negative 50. That's kind of fun. Let's do another 500. Okay, here we go. 17, 9 of hearts, so that's 16, and he's got Jack of clubs. I'm going to lose this one too. There's no way. Well, let's just try a hit. Oh, hello. This is pretty good. I think I'll stand. Yes, I won. I'm back to breaking even. Let's try one more. This time let's do 1,000. $1,000, man. Okay, I've got 17 showing. Queen and a 7. He's got a 2 of diamonds. I think I'm going to stand here. Yes, I won $1,000. Look at that. Very cool. Very fun game. All right. Well, finally got this thing working, even though it kind of blew up on me there at the last minute. Surprising, because I had been running this for, days and days in between cuts on the video here while I was testing things out and, doing all sorts of stuff. And I had not lost any chips or had any problems with it up until that moment when I was recording this game. Maybe this game puts a really heavy load on memory. That's a joke. So yeah, I'm not exactly sure what's going on there, but, this has been super fun to explore so far. I'm going to have to cut this here. Otherwise, it'd be a 2-hour long video probably. So we've got the main unit running. The expansion unit appears to be working. And I've got a bunch of drives. And I also want to see if I can get a GoTech working because I need a way to make floppy disks. I have a few that might work here, but I need a way to make floppy disks so that I can actually run them on real hardware, real floppy drives. So that'll be coming up in the next edition. Until then, if you want more videos like this, I'm going to put a video up in the corner or on the side, one of these sides here that you can go watch right now. And I'll see you over there in that video. Thanks for watching.
End of line.